The next topic here is electronegativity for Unit 6. Electronegativity, so covalent bonds are formed when atoms share electrons. So far, we've assumed that all sharing is equal. But do all atoms actually share electrons equally? And the answer to this is no, they actually don't. Some elements just don't share well. The electrons in a covalent bond might spend a lot more time closer to one atom than the other. This might be if you see two toddlers, and toddlers are not the best at sharing, but they will share for a little bit. So if an adult is playing with a toddler and they're sharing, the adult might get about 10 seconds playing with the toy, and the toddler gets 2 or 3 minutes. And then the toddler decides to share again and will give the adult the toy for a few seconds and then take it back and play with it for another couple of minutes. So the sharing is not equal, and it's the same thing here. And it's determined by a property called electronegativity. The electronegativity of an element is the ability of atoms to attract electrons. It's basically a measure of does not share well. How poorly does this atom share electrons? So electronegativity is something called a periodic trend. And that means that we can figure out electronegativity by just looking at the periodic table. So here's how it works. Electronegativity increases from left to right across a period. And it increases from the bottom to the top. So when I am thinking about periodic trends, what I like to do is draw a rough sketch of the periodic table. Just enough so I get an idea of the basic shape. So here's my periodic table. And it says electronegativity increases from left to right. So from left to right, electronegativity increases. And it also increases from the bottom to the top. So this is the basis of our periodic trend. And remembering that noble gases are inert, which means they don't react, they don't share electrons. What is our most electronegative element? And that would be right here, the top right corner, that is not noble gases. And this is fluorine. Fluorine is the most electronegative element on the periodic table. So it's located at the top right. And according to this trend, in general, this area of the periodic table is the most electronegative. And these are nonmetals. In general, nonmetals are the most electronegative elements. So that's the periodic trend, and it's very helpful because all we have to have with us is the periodic table. But in modern chemistry, we can also support electronegativity with data. And so it's measured using something called the Pauling scale. And the electronegativity of an element is measured on a scale of 0 to 4. So the most electronegative element, which we already said was fluorine, because it's at the top right, here it is. has a value of 4.0. And the least electronegative element would be somewhere towards, so most is at the top right, so we're going to go to the left to find the least and to the bottom to find the least. And we see it's actually a tie. These are our least electronegative elements. I need to label these. These have a value of 0.7. So the scale goes from 0 to 4, but we don't actually ever hit 0 because at some point everything is willing to attract electrons to some degree. So you'll also note that the noble gases are not measured on this scale, at least not the first few. So here are some noble gases, and they don't fit the periodic trend. They don't even have electronegativity values. But this data in general supports electronegativity as a periodic trend.